virtual solar panel lab. We will see if the dog back there, Vader, is going to allow this to happen, but we're going to give it a go. All right. So, starting off with our question, how is a solar panel affected by shade or dirt versus chemical energy? You know, like a battery. Well, here's my actual question. I'm interested in getting solar panels. As soon as I can get my daughter out of college, we're looking to fund those bad boys. But I've got a question. How do they function? Now, I know I'm supposed to get up there on the house about every month and clean those things off. Well, I'm supposed to get up on my roof about once every 4 or 6 weeks and clean my gutters. That doesn't happen. So I have a sneaking suspicion I'm not going to get up on the roof to clean my solar panels all that often. Once, twice a year, sure. So how does dirt affect it? Also, I've got a tree right on the side of my house. It's not in my property, so I can't cut it down. And towards the late afternoon, I start getting shade on my property. So how much does shade affect solar panels? Because I can't get solar panels where they're going to be in the sun all day long. Good bit of the day, but I'm going to lose some. So this is a real question to me. How does dirt affect the solar panels? And how does shade affect them? All right, for the materials, we've got our handy dandy solar panel. We've got our voltmeter to see what kind of electricity we're pulling in. But we've also got our motor with a propeller, because just because I'm pulling down some voltage doesn't mean it's enough to run something. And when it comes down to it, that's what I need the solar panels for, generating enough electricity for me to run my stuff. All right, well, let's go ahead and get to it. I'm going to leave it to you to write down the procedures. Remember, they need to be clear enough that when I email your report to my friend in Thailand, he can run the exact same experiment with his students. So here we go. First off, we're going to look at full sunlight versus some cover. Now, ideally, this should be angled up right at the sun. That's normally how you see them. But we notice I'm pulling 335, I lay it flat, and I'm down to 3.33. So I'm losing a little bit from the angle, but not a lot. Let's go on and see what happens with shade. So I'm kind of trading in my manila folder for this so we get a nice bit of shade. So here we go. Also, for what it's worth, if you note, there's 1, 2, 3, 4, 5, 6 actual panels. So it's real easy for me to determine a third, 2/3, or the whole thing. All right, so first we're going to start by covering 1/3. Yep, look at that. I'm losing some voltage. And now if I cover it down to 2/3, losing more voltage. Still only 1/3, you know, still pulling in some voltage. Now I want to make sure I cover the whole thing, make sure I have shade. Yeah, and I'm only getting about 0.27, not much at all. Probably getting a little bit of reflection on the back end of this or some sneaking around. These new solar panels are pretty darn good. They'll pull electricity down with virtually any light whatsoever. So anyway, that's the shade question. Now, let's look at dirt. What happens with dirt? So what I've got here is just some good old-fashioned sand. Now, what I'm really interested in is kind of like your car. You know, you go out there and you write the wash me on it. It's time for mom and dad to wash it. Well, that's what's going to happen to these panels up on my roof if I don't get around and clean them. Now, we're not going to take that kind of time here, but I can simulate it with some sand. So we're going to start off with some fairly light covered sand. So, you know, taking a look at it, it's pretty dirty. You know, if I were to look at a car that looked like that, I'd say it was pretty dirty. But man, check that out. That's still pulling down 0.32, 0.3. I didn't notice what it was when I tossed it on there, but you could. Pretty dirty. So let's make that thing really dirty. Like I haven't been up there for like a year. Now I'll be honest, that if I had a car looking like that, that's like I just went mudding or something. Holy cow. Take a look at that. Pretty darn dirty, but it's still pulling down a lot of voltage. Matter of fact, I can't imagine my solar panel getting anything near that dirty before I had a chance to get up there and do it. I'm still pulling down some pretty good power. So anyway, you'll have to draw your own conclusions from that. But let's take a look at what happens when we go from a voltmeter to something actually pulling down power. So we're going to go ahead and clear this out, reset, go again. Now this gets a little bit tricky, so I'm going to pull my assistant in to help me out here. So my daughter's going to come in and hold this for me, because I just realized normally we're running this lab and there's multiple of you in it. So there we go. So she's going to kind of hold that while we make sure. It did. It broke. Look at that. She broke it. All right. Pretty good connection, and I don't want to see it. They do. So fan's running pretty good. Let's go back to shade. All right. So here we go. 2/3 shade. Wow, look at that. Stop. Back on. Just for the heck of it, I only covered one of the 6 panels. And I can tell it slowed down. She can feel it. Cover 2, it's gone. I mean, I could go ahead and cover the 3, but obviously when we lost 2/3, we lost power. Sun back, it's on. Now when we looked at the numbers, we didn't lose much power when we did 2/3, but the fan is not running. So there we go. Full sun, 1/3, dead. 2/3, dead. Obviously dead. All right, let's go to the shade thing. So once again, you already had your hypothesis, what you thought was going to happen. Now let's take a look at sand. Let's go back to that light dirt. You know, I could see it getting maybe that dirty, and fan's still running pretty good. Now we're going to go with the heavy dirt. And that's pretty dirty. Check it out. It did shudder, but fan's still running. Just for the fun of it, because I know this is exactly what you guys would do. What does it take to kill that motor when it comes to dirt?
Oh, no.
She felt it shudder. There we go. I can't imagine my solar panel up on the roof at an angle ever getting that dirty. But there we go. All right, guys, let's take a look at the back side of that. Now, granted, your sand was on some. When we look at the conclusions, what next, and etc. Well, the conclusions, it all depends on what your hypothesis was. Draw up your own. Was your hypothesis supported, not supported, or it was inconclusive? Sort of depends, but fill that on out. What next? Well, a good scientist would always have new questions to arise, have something else they want to try. What can we improve? Well, what's next for you? If it was this, big scale, how else would you want to test these before you invested like $15,000 to put them on your house? Now we're going to get down to our independent, dependent variable, and your control. Guys, always ask yourself the same questions. For the independent variable, what did I change? So in this experiment, what was the one thing I changed? Remember, we kind of ran 2 experiments there. For the dependent variable, you ask yourself the D question. What was my data? Literally, what data were you recording? That's going to be your dependent variable. And lastly, it comes to our control. Remember, there's a control group and the experimental group. So what was the control group? And if you're still unsure, you always ask yourself this question: what's normal? So what was the normal here compared to what we were actually experimenting with? Anyway, hope you guys enjoyed the virtual lab, solar power energy. Sorry we didn't get to do it at the school with you playing with the materials, but hopefully we all learned something, and have a good one. I'm out.